lucky last talk for today. We've got Nathan Jameson, and he's going to talk about Intron 1 mediated regulation of EGFR expression in EGFR-dependent malignancies.
Thank you for this opportunity. And thank you for the opportunity to make the joke about saving the best for last. EGFR is a receptor tyrosine kinase activated upon ligand binding and dimerization, leading to many different cell growth, differentiation, invasion, and survival pathways. EGFR is altered in many different cancers. Specifically, I'm going to focus today on GBM and head and neck cancer. In GBM, it's altered, meaning mutation or amplification in approximately 55% of cases, and in head and neck cancer in about 15%. But we see protein activation and overexpression in a higher percentage of these cancers. In GBM, we see in about up to 70% of these cases, and in head and neck as much as 85%. So we believe that this indicates that there may be a transcriptional control of the expression of EGFR. So that led us to the question, are there cis-acting elements controlling EGFR gene expression irrespective of copy number? So to begin answering this question, I performed H3K27 acetylation ChIP-seq on a panel of different cell lines from both GBM and head and neck cancer. And when you look specifically at the very large first intron of EGFR, we see high activation and high deposition of H3K27 acetylation in two specific regions that I've highlighted here that we're calling superenhancer 1 and superenhancer 2. To begin understanding if these are actually active as enhancers, I segmented these superenhancers into multiple 2 kilobase pieces as well as a negative control region and cloned these into a luciferase reporter construct. And what you see when you transfect these luciferase reporter into different glioma and head and neck cell lines, the highlighted red regions are regions that we see high levels of luciferase activity, and these correlate very strongly with high activation of H3K27 acetylation in both GBM and head and neck. These same regions that we've identified as being highly active by luciferase activity, I've also highlighted here to show that when you have activation and presence of H3K27 acetylation in these regions, we have a correlation of EGFR transcript levels. So high acetylation, we also see high EGFR transcript levels in these cell lines. To begin understanding what the consequences of loss of these enhancers has on EGFR expression, I undertook an enhancer deletion approach via CRISPR-Cas9 editing. So I designed guide RNAs that flank the highly enhancing regions of both SE1 and SE2, isolated homozygous clones, and looked at EGFR transcript levels. And what we see in two glioma cell lines, U87 being low EGFR expressing, and SF767 being a high EGFR expressing, and Cal27, a head and neck cancer, low expressing, and HN12, a high expressing, there's a significant decrease in EGFR transcript levels when you make either SE1 or SE2 deletions with some cell type specificity. And in the one cell line that I've been able to make a double deletion, we see a combinatorial effect that when you lose both superenhancers, you see an even stronger, more significant loss of EGFR expression in these cells. Finally, we wanted to identify critical transcription factors that may be involved in the presence and activity of these superenhancers. So we also integrated a TAC-seq from these same four cell lines to go along with the H3K27 acetylation and did motif finding on all the peaks for all the data sets indicated here. And what we find is that the most significant motif in every case are members of the AP1 family of transcription factors. So to confirm that AP1 is actually present in these regions and active, I performed ChIP quantitative PCR on 4 different regions within each of these, both superenhancer 1 and superenhancer 2, as compared against a negative control region. And what we see is that in cell lines that have high EGFR expression and high acetylation, we have high presence and high binding of both the FOS and June AP1 family members in these cell lines. So in conclusion, I've shown 2 EGFR-driven tumor types that have signatures of enhancers in the first intron of the EGFR gene. These are functional by luciferase reporter assays, and deletion of each enhancer has a significant deleterious effect on EGFR transcript levels. And finally, we believe that the AP1 transcription factor family members may be responsible for enhancer activation and activity in EGFR intron 1. So as some future directions, I'd also like to utilize a dead Cas9 crab system to repress very targeted regions within SE1 and SE2, and assess EGFR transcript levels, as well as using chromosome conformation capture to confirm significant interactions between these regions and the EGFR promoter. And finally, use shRNA approaches to knock down these AP1 family members and show impacts on tumor growth. And with that, I'd like to thank Dr. Frank Fernari and the entire Fernari Lab, as well as my funding and collaborators. So thank you.
Yeah. Look, it's beer o'clock, everyone, so I thank you for your attention and thank our speakers for a fantastic session this afternoon. Thank you.